Here we go, folks. Number 14, the dreaded related rates problem. Water from a cone with a 60-inch diameter. So it's a cone. Let's draw a cone. Here we go. 60-inch diameter. So D is 60 with the height of 15. Is leaking out. So it's a negative rate. At a rate of 5 cubic inches per minute. Okay. Find the rate at which the radius of the water is decreasing. So I'm going to try to find dr dt. Okay, when h is 5. So we're going to rip disk this problem. We're going to rip disk. All right. So let's go. Let me zoom out a little bit so we can. So we're going to rip disk. Okay. So we read it. You can read it again if you want to. Want to identify our variables, givens actually. So in this one, we know that we have, D is 60. This implies that the radius is 30. It's half of it, right? H is 15. I was labeling them as I went around. The RDT is what we're trying to find. H is 5. Notice we have two H's, so this is the one we're going to plug in. We're going to plug this in. I think the overall height has to do with the just the overall absolute height of the cone here. We're going to see that when we draw the picture. And then I think that it's leaking out at a rate of 5 cubic inches per minute. So leaking out this minus rate here, and 5 cubic inches, cubic means V, right? And because it is, here we have here, per minute, inches per minute, it's going to be a rate. So this is a rate, so it's d dt, and it's cubic, so it's dv dt. And dv dt is 5 cubic, so inches cubed per minute, and it's negative because it's leaking out. Okay? I'm going to go ahead and write that dv dt is negative 5 inches cubed per minute. Okay? And now we're just going to draw a pretty picture now. I've identified some of our givens. Now we need a picture here. So in this picture we should have a cone, okay? And what's going on with it? So 60-inch diameter, so the radius is 30. And we said the maximum height was 15. And there's a certain amount of water in here, right? So you don't want to draw it to the top because you don't know how much of the water is there. So we're just going to assume that it's just like leaking out, and the total height is 15. But you don't know what's happening here. And it says, and I want to find dr dt. That's what I'm trying to find here. That's the money. And h is 5. We're going to plug that in. Okay. So now we're going to need an equation. Okay. Oh, by the way, you should have also have maybe drawn like a little hole here, and water is seeping through. And my equation for a cone is the volume is equal to. Why do I need volume versus anything else? Because I know I'm going to need an equation with volume, because when I take the derivative with respect to time, I'm going to need to have dv dt. So we know V is equal to 1/3 pi r squared h. This is the volume of a cone. If you don't believe me, look it up. I have my equation. Now I'm going to differentiate with respect to time. So I'm going to go d dt here. So d dt this guy. So d dt of V is dv dt. Constants go along for the ride, equals 1/3, or pi over 3, same thing, times d dt of r squared h. Okay? So automatically when you do this here, another alarm should kind of go off in your head when you're looking at these problems here. You should think of something here. Why? What is one of the things you should be thinking of? You should be thinking of the product rule, right? And when you do the product rule, f prime g plus g prime f, you know you're going to have a drdt and a dhdt. The issue with this is that we don't have, we're trying to find drdt, but dhdt is not in the problem. It's not given anywhere, right? So if you were to do this out, so derivative of the first, 2r times drdt times h, plus derivative of the second, dh dt times r squared. See, I can find most of these, but I don't know dh dt, so this is problematic here. So I need to fix this here. So this means if you have an extra rate or an extra variable, this means, let's zoom in here, I need another equation. With your two variables, which are r and h. So how would I find that? Well, you kind of have to this is a really tough part here. So if you imagine the height of the water to be this here. So let's just call this h, because that's like the height. And you know the whole distance is 15. And you know this is 30, and this is a certain radius at that height of the water. So let's call this r. We did this last week. If you draw this out over here, you basically have is one triangle that's inside of another similar triangle. I kind of gave it away there, right? You're going to use similar triangles, okay? So this is 15, that's 30, and this is h, and this is r here. So we're going to set up a proportion. So we know that h is to r as 15 is to 30. And this is not drawn to scale, obviously. So I'm going to reduce this really quick. H over r is 1/2. And I'm going to cross multiply. So 2h is r. So I know r is equal to 2h. And now you have to think now. Now, do you want r's or just h's in your equation here, right? Because we don't want this here. So I'm going to just get rid of this guy here. So I want to get rid of one of these here. And I know I'm trying to find drdt, right? So I probably don't want to get rid of r. So that means I need to get an equation for h, which means I need like h equals something, right? And I'm pretty close here. I have 2h equals r. So if I divide by 2, I'm going to get h by itself. So I know that h is r over 2. And now I'm going to take this guy here, and I'm going to, whoa, it's a little far. Sorry, it's kind of messy. It's like navigating through traffic. I'm going to plug this in for here, for h. Okay? I'm going to do this on a separate sheet because it's just too messy. So what I have so far is dv dt equals pi over 3 times ddt of r squared times h. Remember, we don't want to take the derivative of this yet because we will get dhdt and we don't have that. So we're going to use our other equation that we acquired from similar triangles, which h is r over 2, and plug that in for h here. So we get dv dt equals pi over 3 times ddt of r squared times r over 2. So this gives us here dv dt equals pi over 3 times ddt of r cubed over 2. And if you remember, this is the same thing as 1/2. This can be pulled out of the derivative. So I'm going to say dv dt equals pi over 3 times 1/2 times ddt of r cubed. And now I just take this derivative. So dv dt equals 1/3, pi over 6 times this derivative, which is 3r squared times dr dt. And finally, we have our equation. Now we can plug in stuff. So dv dt was -5, right? That was given, where was it? It's over here. H is 5. Oh, look, we didn't even have h, did we? Did we have h? Yes. So we know h is 5. Problem is we don't have r. So how do we find this? Well, we know, we go back to that equation that we used. So we know that h was r over 2, right? And we know that h is 5. So we could solve for r times 2. So r is 10. So then we can plug in 10 here. So it's going to be equals pi over 6 times 3 times 5 squared times dr dt. And now let's simplify. I'm going to take this guy. I can finish this off. This is 5. This is 3 goes into 6 2 times. This is pi over 2 times 25, right? Times dr dt. And now I'm going to bring it up over here. So I'm going to have negative 5 equals 25 pi over 2 times dr dt multiplied by the reciprocal, which is 2 over 25 pi. So I get these cancel, so dr dt equals, this is going to be negative 10 over 25 pi, which is, just take out a 5, so that's negative 2 over 5 pi equals dr dt. Okay.
Aaron Williams and
finally,
please go to Mr. Melvin's room. Aaron Williams
I think I actually,
and Oscar Munoz to Mr. Melvin's room.
and as you can see here, this was our answer, and hopefully I did this one correctly. I have a feeling maybe I messed up somewhere, but you can double check me. So according to this work, it's none of these here, but the concept behind this problem is solid here.